Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations. So let's get going. Problem. Solve d square plus 5d plus 6 into y equals to cos square x. Solution. Firstly, let's find the order and degree of the given differential equation. D square plus 5d plus 6 into y equals to cos square x. Now, identify the highest derivative. Here, d square is the highest derivative, so order will be 2. And the highest power of the highest derivative is our degree. Okay? Or, you can write the given equation as d square y plus 5dy plus 6y equals to cos square x. We know that differential operator is d by dx and d square is d square by dx square. Right? Then we can write d square y as d square y by dx square and dy as dy by dx plus 6y equals to cos square x. Now, identify the highest derivative. Here, d square y by dx square is the highest derivative, so order will be 2. And the highest power of the highest derivative is a degree. Degree is 1. So, we are given a differential equation which is in operator form, which is in form D, right? Which is in operator form D, and also f of d into y equals to some q form. Which is in operator form f of d into y equals to q, where f of d equals to d square plus 5d plus 6 and q equals to cos square x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function, yp is a particular integral. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by taking RHS to 0 or by making RHS to 0, we'll get the homogeneous equation of the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. Now firstly, we'll find the complementary function using the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we are having f of d equals to d square plus 5d plus 6. Now, we'll find f of m by replacing differential operator d by m. Then we'll get f of m equals to m square plus 5m plus 6. Right? Then our auxiliary equation becomes m square plus 5m plus 6 equals to 0. Now let's find roots to this equation. Split 5m as 2m plus 3m plus third term will be as this. Now take m common from the first two terms, we'll get m times m plus 2, and take 3 common from the next two terms, we'll get 3 times m plus 2 equals to 0, right? Then, if you notice, you're having m plus 2 in both the terms, so let's take m plus 2 common. We'll get m plus 2 into m plus 3. Now equate each factor to 0. If you equate the first factor to 0, we'll get m equals to minus 2. If you equate second factor to 0, By equating second factor to 0, we'll get m equals to minus 3. So from this, we'll get m equals to minus 2 and minus 3. Here the roots are real and distinct. Therefore, m equals to minus 2, minus 3 are the roots of auxiliary equation, that is our f of m equals to 0, which are real and distinct. Now let's write the complementary function using the real and distinct roots. We know that when two roots say m1, m2 are real and distinct, then our complementary solution or complementary function will be c1 e power 1 root into x plus another constant into e power another root into x, right? Then our complementary function will be constant into e power 1 root into x plus another constant into e power another root into x. Then we'll get y is equals to c1 e power minus 2x plus c2 e power minus 3x. Now let's find particular integral. We can find particular integral p by p using 1 by f of d into q, where f of d equals to 1 by, f of d equals to d square plus 5d plus 6 and q is cos square x. We know that cos 2 theta equals to 2 cos square theta minus 1. We can just write this as 2 cos square theta minus 1 equals to cos 2 theta, right? Now, take this minus 1 to RHS, you'll get 2 cos square theta equals to cos 2 theta plus 1 or 1 plus cos 2 theta. Then, cos square theta equals to take 2 to RHS, you'll get 1 by 2 times 1 plus cos 2 theta. Or 1 by 2 into 1, 1 by 2 plus cos 2 theta into 1 by 2 is, let's write it as 1 by 2 into cos 2 theta, right? Now, let's replace cos square x by 1 by 2 plus 1 by 2 into cos 2x, right? Since cos square theta equals to 1 by 2 plus 1 by 2 cos 2 theta, right? Now, this becomes 1 by d square plus 5d plus 6 into 1 by 2 plus 1 by 2 into cos 2x. Now yp becomes 1 by t into, we can just write this as 1 by f of d into 1 by 2 plus 1 by f of d into 1 by 2 cos 2x, right? 1 by f of d into 1 by 2 plus 1 by f of d into 1 by 2 into cos 2x. Now we can write this as, the first term as 1 by 2 into 1 by f of d into some 1, right? Or instead of writing 1, we'll write e power 0 into x. Since e power 0 into x equals to e power 0, which is equals to 1, right? Plus constant 1 by 2 into 1 by f of d into cos 2x. Now, we'll find the terms under brackets separately. Okay, if you want, you can just name this as some yp1 and this one as yp2. Okay, for our convenience. Let's find yp1 firstly. Equals to 1 by d square plus 5d plus 6 into e power 0x. Right? This is in 1 by f of d into e power ax form, where it is a real number. And also we have f of d equals to d square plus 5d plus 6. Let's find f of 0 equals to 0 plus 5 into 0 plus 6 equals to 0 plus 0 plus 6, which is 6, not equals to 0. Since f of 0 is not equals to 0, then we can just replace d by 0. Okay, we'll get right, equals to 1 by 0 plus 0 plus 6. 6 into e power 0x. Since e power 0x is 1, then you'll get 1 by 6. Therefore, yp1 equals to 1 by 6. Now let's find yp2. yp2 equals to, I'm taking yp2 as the terms under bracket. Okay, so now this is of 1 by f of d into some cos ax form, right? We are having, firstly we need to find d square, which is given by minus a square, which is equals to minus, for a equals to 2, we get minus 4. Now let's see what happens if we replace d square by minus 4 in the denominator. Okay, we need to replace d square by minus 4. We'll get minus 4 plus 5d plus 6, which is equals to minus 4 plus 6 is 2 plus 5d, or 5d plus 2, which is not equals to 0. Okay, by replacing d square by minus 4, we'll get the denominator, some denominator which is not equals to 0. So, we can replace d square by minus 2 square, which is equals to minus 4. Okay, this one. Then we'll just write the same thing here. We just did some rough work. Okay. Let's replace d square. I'm just writing the same thing here. Cos 2x equals to 1 by 2 plus 5d into cos 2x, which is equals to 1 by 5d plus 2 into cos 2x. Now, we can write yp2 as 1 by 5d plus 2 into, now multiply and divide with 5d minus 2. See here you're having 5d plus 2, right? So we'll change the sign. If we change the sign here, we'll get 5d minus 2, right? We'll multiply and divide with 5d minus 2 into cos 2x. This becomes 5d minus 2. 5d, 1 into 5d minus 2 is 5d minus 2 by 5d plus 2 into 5d minus 2 into cos 2x, which is equals to 5d minus 2 by, in the denominator we are having a plus b into a minus b, right? We are having some 5d plus 2 into 5d minus 2, which is of a plus b into a minus b form, which is a square. We can write this as a square minus b square into cos 2x equals to 5d minus 2 by, we can write 5d square as 25 d square, 5 square is 25, d square minus 2 square, 4 into cos 2x. Here d square appears again, right? So what we'll do, we'll again check it. Check the denominator. So replace d square by minus 4, you'll get 25 into minus 4. Minus 4 equals to minus 25 into 4 is 100. Minus 4 is minus 104, which is not equals to 0. Okay, by replacing d square, we'll get some number. We got some number which is not equals to 0. So you can replace d squared by minus 4. Always remember that the denominator should be not equals to 0. If it becomes 0, then the total term becomes undefined. If you get something 0 in the denominator, say if you replace some d square and you got the denominator 0, then you'll get 5d minus 2 by 0 into 2x, which becomes undefined. Okay, but in our case, the denominator is a number which is not equals to 0. Right? Now, what we'll do, we'll just replace d square by minus a square, which is equals to minus 2 square equals to minus 4. Then this becomes 5d minus 2 by 25 into, I'm writing the same thing, okay, minus 4 into cos 2x is equals to 5d minus 2 by minus 100 minus 4 into cos 2x, which is equals to 5d minus 2 by minus 104 into cos 2x. We can write this as 1 by minus 104 into 5d minus 2 into cos 2x, which is equals to, you can write 1 by minus 104 as minus 1 by 104 into 5d cos 2x minus 2 cos 2x, which is equals to minus 1 by 104 into 5 into, we know that d equals to d by dx, then you can write d as d by dx of cos 2x. That is, we need to find derivative of cos 2x with respect to x. Okay, is equals to minus 1 by 104 into 5 into derivative of cos 2x is minus 2 sin 2x minus 2 cos 2x, which is equals to minus 1 by 104 into minus 2 5s 10 sin 2x minus 2 cos 2x. Now, you can either multiply these two terms with minus 1 or just take minus common from these two terms or take minus 2 common from these two terms. So let's take minus 2 common from the two terms under square brackets. Okay, we'll get minus 2 into 5 sin 2x plus cos 2x. See, minus 2 into 5 is minus 10 sin 2x, minus into plus minus 2 cos 2x. You'll get the same thing, right? Now, just write this as minus 1 into minus 2 by 104 into 5 sin 2x plus cos 2x, right? Which is equals to minus 1 into minus 2 is 2 by 104 into 5 sin 2x plus cos 2x. Okay, these are YP2. Therefore, YP2 equals to Now we can replace the result obtained from yp1 and yp2 in yp. Then yp becomes 1 by 2 into result obtained from yp1, which is 1 by 6, plus 1 by 2 into result obtained from yp2, that is 2 by 104 into 5 sine 2x plus cos 2x. Okay, in the second term 2 gets cancelled, which is equals to 1 by 2 6 are 12 plus 1 by 104 into 5 sine 2x plus cos 2x, which is our yp. Now we can write the general solution. The general solution is given by y equals to yc plus yp. Then we'll get y equals to yc. We have yc c1 e power minus 2x plus c2 e power minus 3x plus yp 1 by 12 plus 1 by 104 into 5 sine 2x plus cos 2x. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.